Hello, welcome to our October webinar. Apologies for the delay there. We had a bit of technical issues, and really thank you for staying on the line for the last 20 minutes. This is our October webinar by Erlang Solutions entitled 16 Lessons to be Learned Using the Beam. So we are joined by Joe today, who has built servers in Erlang and Elixir on a vast number of projects, and he's also a great speaker. Recently, he was at Code Elixir London, so that name might be familiar for some of you that attended there, and he's also arranges meetups in Kraków, Poland. This webinar is part of our Open Erlang series, celebrating 20 years of open source language. We have been celebrating meetups, webinars, parties, blogs, and we've just announced our London party, which will be taking place on the 8th of November. This is a free party with food, drinks, and entertainment, so do sign up for it. You can find the details on our social media. It's an Eventbrite link to RSVP. So we'd love to hear from you today regarding our webinar. You can tweet us. Our Twitter handle is really straightforward. It's at Erlang Solutions. You can also submit a question using the questions box in this platform, and we'll have a quick Q&A at the end as well. So as you can tell, we've already had some technical difficulties today, but hopefully we won't have any more. And now it's over to you, Joe. Enjoy the webinar.
Hi, everyone. So yeah, thank you, I think, first of all, to Erlang Solutions for organizing this. And yeah, again, apologies for the technical difficulties. I think, as you can probably tell, this won't be as interactive as I wanted this to be. So this is a Jupyter notebook, and this is sort of static content now. A lot of the stuff in here that we're sort of going to work on together, examples and such, we'll have to sort of pull yourselves, I suppose, and get working. But I will walk through all of that and explain it as best as I can. So what is this about? So it's basically my 3.5 years working with Erlang and Elixir, sort of distilled into 16 sections. It's sort of in the style of Strunk and White, so a lesson learned, an example, something like that. So a lot of this is from the Beam. Learned a lot of this sort of alongside working with Erlang and Elixir, pulling in lessons from other communities. So if you think about it, for example, Lisp has been around for a very long time. A lot of other functional programming languages have been around for a very long time. And they've learned all sorts of things in these years that we can sort of apply to the Beam. And a lot of this is about that. So like I said, this is as much from other communities, I think, as it is sort of Beam-centric. And there's a mixture here of things that are immediately useful, so kind of practices you can take and put into practice straight away, and others that are more high level, so they'll need a little more thought, I suppose, sort of longer term, bigger goals, bigger aims, and of course the payoff is bigger there as well, much more value. So if we get started, first lesson is basically that the umbrella only enforces the boundaries we create. So this is sort of as high level as we can get, or as big picture as we can get with Elixir when we talk about architecture or design, right? So if we put decisions aside, like database we're using, or the queuing system we're using, or exactly what it is, or how it is we're delivering certain aspects of our system, if we put that aside and say, let's concentrate on the Elixir side of things, then the way we decompose our application or a service, for example, at large, a project, also sort of comes down to the umbrella. And one of the things we sort of hear people say often is that the umbrella helps you enforce boundaries, and it certainly helps you enforce boundaries, but I think the sort of big lesson here is that it'll only help enforce the boundaries we really create. So whatever lines we help to sort of redraw, those are the lines that, or the boundaries that it'll enforce, and that's what it'll do. So this is sort of just like a module, right? Any API you define for a module, the umbrella is the same. It's only going to be able to enforce that very particular API, and so it's, I guess, the way to get this right and to sort of not make a sort of spaghetti code or sort of tangled dependency issue with an umbrella is to really concentrate on things in a way where they look like dependencies. So if we take the example below, we have an umbrella directory here for a particular service, and we're probably concentrating on delivering functionality for a server. But inevitably, we end up writing at least fragments of a client as well, which we might put in an application or an umbrella directory of its own. And then the model there is sort of the thing that the client and the server have in common. So while the server, for example, might encode a bunch of requests, the client might decode those, or whatever the relationship is there. One thing that they both have in common ultimately is the model, right? So it's the kind of data that gets sent on the wire, not necessarily how it gets sent. Obviously, the client and the server do their respective parts, but they both rely on that model, and so they can both pull that in. And then if you're doing end-to-end or system tests, maybe some of the integration tests, that could be an umbrella app of its own too, and of course that would rely on both the client and the server. So you'd pitch the client against the server and make sure that works. And so this is the kind of relationship we could go for between our applications, or rather across our applications, when we're looking at umbrellas. And so what we're really avoiding here is sort of calling into each other from the various apps under the umbrella. The relationships really only go one way. So the client and the server depend on the model, and then those two might be sort of pulled into the test. So thinking about the dependencies there and their relationship is probably the biggest takeaway here at a high level. If we get them wrong, it gets really tough to work with umbrellas, not only because you have to configure them separately and various other issues like that, but just because working with the kind of relationship in terms of dependencies gets difficult. So the next sort of lesson learned is around OTP and the source tree. And I think sort of taking a step back and looking at how Erlang and Elixir do concurrency, Erlang made it practical, perhaps the first language to do that with processes and message passing. And it did this a long time ago, of course. And it also had primitives for fault tolerance, so the monitor and the link, and they sort of over time built OTP. And so this is Erlang's or Erlang and OTP's sort of biggest contribution for me in the field, because they really make concurrency declarative, right? So you can take an application, you know what that does sort of intuitively, or rather through convention, and you can take the supervisor, we know what these do, and again the workers and finite state machines and things like that, and we know what these do, and we can take a look at them from a high level and say, okay, this is really declarative. All of a sudden we don't need to concern ourselves with spinning up processes and doing all of this sort of manual work, as it were, or really focusing too much or a whole lot on how it is things fail and succeed. And so OTP really makes concurrency declarative, and I don't think any other language or any other platform can really say that. So I think if you go to other communities, some might sort of say concurrency can be hard, and it can be hard if you have an antiquated thread model and you don't have a good means to communicate, a good means to handle failure, then concurrency can definitely be hard. But when we think about concurrency in Erlang and Elixir, it's really there, and perhaps languages like Go, which make it easier to work with concurrency, is that really it should make our software easier to read, more reliable, of course, but it should really be there to capture something that we can't capture as easily, say in older languages or in other languages, for example. So it's really there as a sort of abstraction to help us, and sort of going along this path, OTP being declarative, we can really sort of see that with the directory tree, right? So if we do a tree on the lib directory of an Elixir application, this is what we see, and it's very similar with Erlang, right? This all came from Erlang and some of the conventions we see there, where we list an application, we have a supervisor, perhaps perhaps more than one, and workers that would reside underneath those supervisors, and we're able to gauge straight away what the concurrent sort of aspects of our project are. And so big takeaway, or the sort of big contribution I think that the OTP really sort of gives the field is just this declarative way of looking at and specifying, describing, writing software that spells out concurrency for us. And similarly, if we take something that's much closer to our domain, so if we're writing some business logic, what we're looking to do there is basically refine what it is we understand about our domain and really capture that. And so this part is a little more applicable to Elixir because of how its hierarchical namespacing works, for just the mere fact that it has hierarchical namespacing. Although we can sort of achieve a similar effect with the Erlang source code now, where you can nest directories. You can put source code, Erlang source that is, into directories or nested directories. And what we see here in the tree listing here is basically our domain decomposed, or a domain composed of all of its sort of subdomains, if you will. So POX is an HTTP library. There are obviously more than one version of the HTTP protocol, and that's what the v1 _1 directory captures. That's the only version we sort of support here. And then you can see from the listing, right, that we have a request and a response, and these are the big HTTP entities. So they have a small domain of their own, and of course there's the wire format. And again, just through the source tree or the source listing, on a sort of file by file module basis, we can tell that the wire format consists of 3 parts: the body, the header, and the status line. And then the entity that's responsible for piecing all of those together is wire format, the module wire format, which resides in wireformat.ex. And just sort of by looking at the source tree there, we're able to perhaps intuit that we can use a request and response, perhaps their structures, and serialize those values that we construct through the wire format module. And of course, this is quite a technical domain, so this is HTTP, but our business logic is just the same. So see this time and time again with clients that we're able to take higher level requirements, right, and perhaps iteratively refine them and take a bigger model, or the domain at large, and successively build smaller and smaller constituents for that domain. And we're able to capture the source tree, capture that domain very declaratively, again, through the source tree. So that's a sort of, I think, that sort of draws from ML, where you have hierarchical types, or type hierarchies, and of course from much more mainstream languages like Java or Python, where we have modules there as well, and hierarchical namespaces there too. So I think one of the big sort of the big difficulties, or the big challenges, right, in computer science and software engineering are really a lot about naming. And in Elixir and Erlang, we have generally on the beam we have this idea of MFAs, or modules, functions, and arguments, and we work a lot with that. And so the module, the function, and sort of the variable are the entities that we really give us naming constructs, right? So if we think about this more generally, or again, if we step back, then we could say that sort of naming and basically defining a domain, or breaking it apart, and building up towards something, it's all about building context, and in a lot of cases it's about restricting it, right? So if we start with a high level entity and we decompose it into smaller entities, this is all about making the context that we're given sort of smaller and smaller and smaller. and it's sort of well acknowledged fact, right, that naming things is hard, and that really this is what we do as engineers. So if we take the module, like I said, it's a construct for naming, right? We have a hierarchical namespacing in Elixir, and Erlang it's a flat naming structure. But our module names should be conveying the most information about whatever domain we're currently working with, right? Both functional and operational. And so the module is the entity that should absolutely convey the most information. So if we look at the example that we have here, if we ignore the package name POX, then underneath that we basically have a sort of successive pieces that sort of go deeper and deeper into our domain. So we know this is an HTTP library. If we look at the module name, we know this is dealing with a particular version, and we know we're doing formatting that is for the Y format, and there's this particular aspect there that we have to be able to write out, and that's the status line. And so that module name just gives us well, basically as much information as we can really communicate. So that is more so than any other construct. And so for me, if we sort of look at Elixir now solely, it's just that the hierarchical namespace there has got to be one of Elixir's biggest virtues, because it's able to convey so much information, right? With that one construct, and likewise we can improvise something similar with Erlang, and I really sort of encourage us to do so. So if we go sort of one level down in the sort of naming constructs, we obviously have function names, and all I have to say there is that they sort of convey an intermediate level of information, right? It's quite difficult to say, you know, how much you should really spell out in a function, but I often find that when we've got like the module name right, and we've got all of that information in there, that even a one-word function name like write and read or encode and decode is enough to convey exactly what we're doing. So just to note, like I sort of suggested or hinted at before, just a moment ago, encode and decode would probably be better names for the write and read functions here, just because these don't really write or read, right? They encode and decode. They don't have a side effect, right? So moving on, I think one thing that's sort of very contested is the idea of short variable names, but this is sort of taken straight out of the practice of programming. So this is Kernighan and Pike. So it's a well-known book. It's a popular computer science text, and what they argue there is that we should really be able to use, or rather names, for whatever identifiers, be they modules or function names, variable names, should really go according to the scope that they sort of reside in. So if we take a variable name, it already resides or within a sort of function, which could have a small name. But if you look at the module, the names there are much more global, right? So the module should convey a lot of information, and all the way at the bottom, a variable, it should be acceptable that you should be able to tell what the variable is, for example, just through the rest of the context, the scope that it resides in. And so there's not much more that X in the write method, in the write function, or the read method could really be here, right? Except for some data that lets us write out a method, a path, and whatever it is that we need to do here. And so if we sort of take that and put it side by side with the functional sort of philosophy, which we'll touch on a little later on as well, is that we don't have side effects or side causes, right? We don't have as many of them. We try to focus on really building values, using expressions to sort of manipulate them, functions perhaps, but it's a very value-centric or data-centric sort of paradigm. And the fact that we don't have side effects and side causes means that we can really have an even more restricted sort of context or even more restricted scope. And so variable names, really, if we've been able to capture our domain with the tools we have at our disposal in a functional language, then really at that level we should be able to use very short variable names. And so one of the sort of what I consider good practice is that if I need, or if we need to use very long variable names, we know we can, or it might be a sort of point for improvement where we can take those longer variable names and say, okay, how can we refine this? How can we narrow the scope? How can we do this better to get those much smaller? Because really, short names should suffice because a function does most of the work, for example, and a function resides in a module. So the other sort of observation here is that certainly the sort of 1, 2, 3, 4, 5 piece module name here is definitely sort of unpleasant, right? Very long. But with or without namespaces, if we're really trying to communicate whatever it is we're working on, the length will be the same, right? Regardless of whether you have a hierarchical naming system or not. Either you're going to have to sort of end up shifting a lot of that naming into a function, which doesn't sort of feel right, or you just end up sort of making it a whole lot more flat. But either way, if we've sort of done our decomposition right, then we'll probably find that we only need to go one level in the namespace up or one level in the namespace down. And so there's a sort of contradiction here, because in the read function we have a quarter status to assert that we know a certain status number is actually known. And the reason why this is sort of going, well, let's see, 2 or 3 levels in the namespace up is because it actually doesn't belong here, right? When we're reading the wire format, the HTTP wire format, at that point we really shouldn't be testing whether or not a status number is something that we know, right? All we're doing is reading off the wire. And so that should be sort of a high level, maybe a protocol level check that we do, and that should reside higher up. And so this is sort of an example, not a deliberate example. I noticed this after I put this together, but it's really sort of illustrative of what I'm trying to say, which is that if we're using these verbose names, it sort of suggests that we could be doing something a little differently and move it elsewhere where it might fit in better. And so I think that's a big takeaway in terms of keeping code clean and readable for the future. So sort of very related is that I'm sure a lot of us have sort of seen module names, function names, and variable names or parameter names, arguments, where we see a lot of repetition in the naming, right? And so again, for me, that's another suggestion where a common prefix, a common infix, or a common suffix might suggest that we can perhaps refactor something that we're doing to make or spell out our domain better. Maybe there are entities we can move further up the tree or further down. So if we take the example here, we know we're sort of dealing with HTTP requests, so it doesn't help, for example, to spell out the HTTP before the post function. And sort of likewise or similarly with the parameter there, we already know we're dealing with a request. There's no reason to even call it a request. We might call the parameter data, but what else could it be, right? So the reason why this is sort of again sort of important is because we're taking the sort of functional approach and we're saying what we're really doing is concentrating on the data, and we have such a sort of disciplined approach about how we use data, how we use values, that we really shouldn't need to be so explicit at the function naming level and the variable naming level. And we should really be able to shift a lot of that, for example, upward. and just make that easier to read, so less words to read, and definitely more information being communicated. So I think this is sort of one of my favorite lessons on the Beam, or sort of alongside the Beam, right? Because what we often say in the community here is that the processes are really for isolation. So that is, they're about fault tolerance. If something goes wrong, then it's sort of isolated and it doesn't have an effect elsewhere, of course, unless we want it to. And that's very true, right? If all else process is there to wrap up that failure and make sure that it doesn't sort of spread. But really, as a sort of function language, the function should be our main sort of vehicle for isolation. So if we think about it, we don't have as much of a sort of paradigm that revolves around side effects and side causes. And so this is from Paul Graham. He sort of explained this very well, very nicely in the opening chapters of his book on Lisp, where he kind of tries to motivate functional programming and how the fact that we don't rely so much on side effects, that the sort of functional, value-centric, data-centric approach really helps to isolate failure, right? Isolate failure as much as it helps to sort of isolate whatever it means to succeed in terms of computation. And so this is what we might call intentional programming in the Erlang world, and in the Elixir world, I think we call it assertive programming. So Jose has a post on that, and I'm sure Joe Armstrong also has a post on what he means about it with regard to intentional programming. And the idea there is that really the function should be our vehicle for restricting sort of the context or the scope under which we're working, right? For sort of successive smaller and smaller pieces of our domain, and in doing that, it should spell out what it's doing, but it should be restricting things in such a way that if something goes wrong, it's very clear, right, from the function's context and whatever locals we have in the function itself, to be able to explain failure. So if we combine this now with the Beam sort of philosophy, which is that processes are fault tolerance, as soon as something goes wrong, because a pattern match fails on a particular line, for example, which is what I'm trying to illustrate with the read example. So here we have the protocol being the protocol string being matched on the third line down. If that goes wrong, we know straight away that the process is going to crash, for example, and we'll get a really clear error message that tells us, okay, something went wrong on line 3, and this is the issue we had. And so to really exploit that idea that processes are about isolation, this idea of intentional programming, assertive programming, and really the whole sort of functional approach behind sort of restricting side effects and cause, or rather cause and effect, and really sort of having a pure sort of approach to things is able to sort of help us in terms of debugging. Or it might help, for example, to such an extent that there's very little debugging to do. And so if we want to make sort of maximal use of the idea of processes and what they mean with regard to fault tolerance, then sort of functional approach is the way to go, just to get the most information out of whatever it is we're doing, or whatever it is that may have gone wrong. So I think we all sort of come to functional programming, and we become used to the idea that sort of about using data, manipulating data, really focusing on our data. And I think one of the things we sort of neglect occasionally, or sort of write off after coming from a different and perhaps object-oriented, is the idea of abstract data types, right? It's really important to place or to identify and capture an entity in a module, and then build a lexicon, a vocabulary, right, and the right nouns and verbs that we want to use for that entity into the module and be able to manipulate it however it is that we want to do that. And so even though definitely functional programming is about a sort of pipe, if you will, or something along those lines, building an abstract data type of sorts is sort of paramount to making our logic clear. It's not simply about those transformations, we have to give them a name as well. So on a sort of related note, occasionally for complex data, using a struct literal, for example, or a simpler value, a list, a tuple, whatever, just simply doesn't suffice, right? We have to do certain checks on bounds for integers, for example, or whatever it might be. The existence of a file or just a sort of check on the value itself, and then abstract away whatever it is that we need to do with those sort of arguments. And so using a literal sometimes just doesn't suffice. And what we really want is a function to help us build that value, or we want to be able to say, give me a default that's sensible. And so some sort of helpful constructor names might be just simply default of arity 0 or instance of arity 1, and then you can pass in whatever data you need to through instance 1 to construct a value. What we have here is a linear congruential generator, an LCG. It's basically a random number generator, so there's some documentation there. Of course, we have the type here. We enforce all the keys that are necessary, so there are 3 of them, and we have the structure definition. So the defaults there aren't particularly reasonable, and indeed, if you want to give the user the freedom to obviously instantiate a particular random number generator, then they're going to need a method or a function that they can use to do that. But at the same time, the inputs have to be checked, so they have to follow certain rules, and that's what instance arity 1 does here. And then it takes that information and it builds whatever abstraction, which happens to be a function or a closure in our case, around that. And default does a similar thing, except it fetches sort of default configuration, if you will, from the application environment, and you can put that configuration, so something that might normally be hard coded or put into an attribute name, if there's sort of sensible defaults that really sort of belong to the application itself, then you can put them in the application resource file through your mix file, and just fetch those when you want to build a default value. So what I was going to say, demo here, was basically putting the values in the environment, which would normally be when you load your application, and of course also construct something there. And if we move on to the idea that we might define a function, where it resides, where it lives in a module, but the context that we're sort of using it in. So that's the application site or call site, if you will, means that a lot of the information we want to really understand what it's doing, how it's working, kind of just isn't there. So the way I sort of try to explain it here is that identify as at an application site might tell us very little about how we're meant to use something. So the sort of scenario here is that we're writing something in another module, and we can't remember, for example, the order of whether we said a rectangle has its width listed first and then height. And so you have to go and search the documentation, right? Because there's no way to really know except to search the documentation, or you might have a fancy ID that lets you do that. But either way, when you're reading it, it's still very difficult to tell, is this width or height, for example. So obviously simplistic example, but I'm sure it won't take us long to think of a realistic one that we've encountered maybe recently. And so one of the ways around that, okay, so let's go to cell 7, where we kind of show what the issue is, which is basically I can't tell if the rectangle is height 3 or width 3. And then the same thing with the number 2 there. And so one of the remedies we might sort of do there is to stick the height and width in variables of their own, and then pass those to the constructor, right? And of course, the left-hand side, or the right-hand side, so the value 3 and the value 2 might have, in whatever function we're currently working with, might have different variable names. So in most cases, we won't be applying assigning constants, but we'll be pulling variables or values out of other variables and then renaming them just so that we can use them in the context of a rectangle to communicate that this is what we're looking to build, right? And so maybe a better remedy for that is to say my rectangle function isn't just gonna it's gonna be arity1 now, and it's gonna take a keyword list that's much more helpful in terms of specifying exactly what those arguments are at call site. So x is sort of canonically about a horizontal length, width, and y, of course, for a vertical sort of length, the height. And so if we use something like that, then in cell 10 we can see how we'd use that, and that just spells out exactly what it is we're doing at call site. So of course we can replace 3 and 2 with variable names, and it becomes very clear from the sort of context of where we're using this, whatever those variables might be called, because they're sort of relevant there and they're good names for that particular scope or that context. Of course, in the context of rectangle, you also want to know what is being ascribed a height and or a width, for example. And so that just really sort of makes things nice and explicit in a way that's really helpful for the reader. And of course, if you don't want to rely on the order there, then you can use the access protocol to pull out the values that you want. And of course, this example is sort of simple, and it's also a bad example because it builds a data structure. So you could, for example, use a struct, and a struct might suffice if you don't need to do sort of checks around, for example, the values that you're passing in. A better example might have been something like an interval. So does a certain number, the number 3, just towards the end of the note section here, does the number 3 lie in the interval that starts at the number 2 and stops at the number 5, right? This is really spelling it out. And if we compare that with, for example, just a 3-arity function as opposed to this 2-arity function, then this is much more able to communicate what we're doing here. And the sort of point you might trip up on is passing something the wrong arity. So it's very easy to call something and make it look like a 2-arity call, or call something and sort of neglect the keywords there, and then you get an error message that's not very helpful when you compile, I think. But nevertheless, this is nice and easy to read. So I think historically, or at least I think it's for historical reasons, some of us program, or some languages sort of use a bottom-up kind of style. So that's the sort of write your main function at the very bottom as opposed to the very top, and then you have all your ancillary functions at the top. And of course, this isn't really what we want. We want to go, when we talk about abstraction, we want to go from the general to the specific, right? So in terms of structuring modules and functions and the insides or the implementation of a module, your whole package, is that we want to go from the general to the specific, and that's top down. And the reason why we want to do that is because we want to read breadth first, right? We want to get the big ideas first. We want to be able to identify a specific piece of functionality given the context of something that's more general or something that's slightly bigger picture. And so this part is basically about how variables are a bottom-up approach, right? Whereas functions are a top-down approach. And what I mean by that is that if we use variables, like the assignment we have here in the module M, in the function F, variables force us to read things in a depth-first way. So there's no way I can read that except to say, okay, here's X, I'm assigning value of this expression, and we've got no choice there except to read that as it's sort of listed. Whereas if we go a line further down and we look at the application of B on X and then G on that, we can read that in a much more breadth first way and say, okay, I can see G is doing something here on B and X, but I don't need to know what it is that G does or what it is that B does, for example. I don't need to know necessarily the value of X just yet. I can pick whatever level of abstraction I want when I look at that. And so in that regard, sort of using functions, sometimes constant functions, is a nice way to have the effect where we're more able to read some complex piece of logic. So not something as trivial as this, but this example helps to illustrate the point where we can read something sort of breadth first, get the bigger picture first, before we read into the details of whatever it is that we're doing. And so in that regard, sort of using functions is sort of lazy approach, right? I can say, let me write this out, and I don't know what a particular function might do. So for example, I don't know what B does, or I don't know what G does, but I'm going to put those in a function. We'll figure that out later and come back to the bigger picture of whatever it is that we're doing. And so you can come back to the implementation details, as it were, later once you have things figured out. And of course, it works the same way with reading. So when you read it, you're able to see exactly you're able to see the bigger picture, and then if you need the detail, you can obviously follow those functions down towards the bottom of the module. So coming to functional programming, I think pattern matching is a big sort of win, right? We're all really happy with that. It's sort of the idea that functional programming is symbolic, and I think for me, certainly when I came to it, it just clicked straight away. It was very intuitive. It didn't have the sort of mundane sort of rigor of iterating through an index, an array, for example. And so I think, you know, the idea that functional programming and pattern matching inside functional languages is really sort of intuitive because it is symbolic. Is a really big drawing point for a lot of us, and it sort of fits in as well with the data-centric approach that we have, right? If you're able to write a nice literal that you can read in a functional language, then it really reinforces that idea that this is a data-centric paradigm. But occasionally our pattern matching can become too big, right? Too verbose and very difficult to read. So what we have in cell 12 is obviously a sort of nested data structure there, and then if what we wanted to sort of demo here was that if we were to write a function to get out the value under bash, then we just have to nest and nest and nest, and it's very difficult to read, right? And then additionally, you have the when clause or the guard there, which also presents some verbosity. And so, for example, we might go for something like kernel get in, or better still, if I scroll up to remind myself about what I'm speaking, is that we'd build data types and APIs around whatever entities we're working with, right? And we'd really aim to push pattern matching to the leaves of of our source code, and use it there, but really aim to build. So use it at the lower level and aim to build abstract data types and APIs at a high level that we can use to work with. It is functional programming after all, so the idea of ADTs and APIs should really reign supreme. So closure is a sort of what I'd like to describe as functional programming's pearl, right? It's such a useful construct. Like pattern matching, when closures get too big, they can become unwieldy and very hard to work with, very hard to understand. What we have in cell 16 is a sort of trivial example again, but it should bring the point home where we're pulling in the variable n to use in our function f here, and the issue that presents itself is that when we have many more variables sort of make their way into a function or into a closure from the environment, and then of course we have many more parameters, formal parameters that we actually pass to a function. It can become very difficult to tell what came from where, and in addition to that, it could be a multi-clause function too. So if it's an anonymous literal there that we're assigning somewhere, pulling all sorts of things into a closure or through closure, then it can become very difficult to understand. And so what's the remedy there? The remedy is to use the other properties of the fact that functions are first-class values, and say, all right, I'm going to build a constructor for this function, and what I'm going to pass in is all the variables that I need to make their way in through a closure, build that function inside this function that I'm able to call and pass the closure variables through, just so that I'm able to make explicit which variables or which values make their way in through a closure. So a big realization was that the pattern matching operator is much more like a let than it is like an assignment, right? In functional programming, we don't concentrate so much on assignment and mutation and changing the value of a variable. I think variable is the perfect word there, sort of changing that statement by statement. In functional programming, we're much more value centric, right? So we have a variable, but the idea is that it's immutable. The value in there is immutable. Just this whole idea of immutability, and that we're much more concentrated on using expression after expression and really concentrating on the value itself to sort of compose expression after expression and build a computation around that idea. So of course, if we need to repeat something, then that takes the form of recursion or higher order function, but it's really about expression after expression and applying those, and it's always about getting a value back. And so I think binding a variable is a really good way to do two things. And that first thing is, if you really need to pattern match something out of a certain data structure, then of course that's how you can do it. But it's also, I think, as time's gone on, I've used it more and more to draw our attention to something an operation that's side effecty or side causey, right? So in most cases, just using a value in place, building an expression, calling a function, using a pipe in Elixir really helps to sort of you find you don't need, or the whole paradigm just doesn't lend itself to really using assignment anywhere near as much as it does to function application and passing arguments around. And so the equal operator can be really sort of helpful if we're very disciplined with its use to just sort of signify that some operation we've done is actually side effecting. So if we move on to the bit syntax, I think this is probably one of the other favorites from Erlang. It's basically pattern matching for binary data. And it's sort of this really interesting case where the pattern matching that Erlang has and its sort of domain has really come together to say, oh, we can build this construct or this syntactical construct called the bit syntax, and it's a pleasure to use, basically, especially when you're decoding stuff or stuff that's perhaps come off of a wire, decoding binary data. So as far as I know, it's unique to Erlang and Elixir, of course, but maybe someone else has adopted that. The example here, unfortunately, isn't so helpful in conveying the meaning, or rather, its utility. If it was a decoding example, I think it would sort of bring the point home a lot better. But the sort of lesson learned there is that, you know, Erlang's domain, and sort of some of the stuff here inherited from Prolog, the idea of pattern matching and this kind of stuff that's common to functional programming languages, has really lent itself to making a construct that's really sort of easy to work with. So we're coming towards the end now. A little bit about processes, or rather back to processes, and that's the idea that processes are there to sort of capture the operational, right? So if we think about functional programming, we have a domain and we're aiming to capture that in a functional core, right? We want to build models in structs, or maybe simpler data types, for example. We do want you know, higher level constructs or modules again that capture those relationships, and we want to concentrate on the transformations that are involved around those entities with the ADTs, with the APIs that we've built. And then, of course, we have operational concerns like servicing an HTTP request, talking to a database, maybe talking to a queue. All of these things that really are an operational domain, and a process is really, when you think about it, it's meant to exercise that domain and deliver it, deliver the operational aspects, right? So if your domain really captures your business logic, it really captures value, right? Then the operational shell that is your process is really meant to take that value and really deliver it to your user, whatever that might mean. For example, by persisting it to a database, because that's important, operationally speaking, sending it out to a queue to get some work done, or just responding back to your client so that they're able to use that. And so processes are there to capture the sort of operational, right? The IO, thread that domain through whatever operational concerns it needs to make its way through to really actually deliver that value. And so I think that's what processes sort of are there for. So I think dependency injection is the sort of next topic, or the next section. And I call it the kind of ultimate functional evil, because considering sort of what we just said about processes, we should really be focusing so much more on the model, and really being able to rely much less on passing, you know, substantial pieces of functionality just so that we can exercise something that's pure and functional, and be able to deliver that. We should have a really clear separation between what is valuable, right, our business logic, and how we've captured that and really delivering that. And if we're using dependency injection, I think maybe that sort of suggests that we can be using or we can be revising whatever it is that we're doing to have a clearer cut between that value and how we deliver it. So today, I'm yet to come across a situation where we were not able, even if we hadn't sort of managed to, given whatever time constraints or whatever, to really have a clean separation. But I haven't come across a case where we're not able to draw a very fine line between functional and operational. So that, again, that's the difference between you know, whatever code captures value, and whatever code really delivers that through, you know, various means. So, you know, you might switch from JSON over HTTP to GraphQL, whatever the operational concern is there, the representation, and then the idea of using dependency injection shouldn't be necessary, because, for example, we should have a process which captures that operational aspect of both using whatever representation we have and really pulling together the business logic and for example, a wire format or a protocol that we're using, and gluing those together. And that separation should be enough to test, even if you're relying heavily on some other service underneath you. So this is our final section. It's a really sort of simple point, something that you can maybe take away today, use it tomorrow, for example. And that's just basically about where we put our assertions in our test cases. So when we think about it, we want, in the case of failure, to get as much information as we can. And if we look at the example here, it tests whether or not all the integers in that list X, more than halfway down cell 24, it tests if they're all even, and of course they're not, because the number 5 isn't even. But when this fails, the assertion would just say that that of course there is basically the only information it'll indicate is that there is an odd number in there. It'll say that the enum all failed. And so what we can do to remedy that, unfortunately, this was something I was going to type up, but what we can do to remedy that is just the assertion into the function that into the function literal that we're using there, and say use an enum each instead, and say is each of these numbers even, and just use the ampersand syntax and the function capture syntax there. Basically move that assertion into the function that we're using to test, and then that'll tell us straight away that the number 5 is the number that that is letting us down here. And so just thinking about making those assertions in a more granular place can sometimes really give us helpful feedback if we're doing a TDD kind of thing, or even if we have sort of a regression suite or whatever you want to call it. So like I said, this was the last section. I guess I'd like to say thank you to all of you for joining. And again, thanks to Erlang Solutions for organizing this. And if you have questions, I'm ready to take them.
Okay, that's brilliant. Thank you, Joe, for all the time that you've taken and the effort that you've put in for our webinar today. We do have some questions. So the first one is, how do we put these lessons into practice in a new or existing project?
So definitely a question that I've heard more than once, right? Because a lot of this is it's just so idealistic, right? We often face deadlines, pressure, all sorts of stuff that ultimately we end up neglecting good practice sometimes. And so I think the way to sort of remedy that is, if you want to take an existing project, then, for example, then you can just say, okay, I'm going to pick one of these, and I'm gonna just do that across my whole code base. I'm going to focus on achieving that this month or this sprint, and then next time around you just say, okay, I'm going to work on whatever else needs working on, whatever functionality I'm building this sprint, if you're doing an agile thing, and I'll also work on improving our code on one other aspect, and just take it sort of section by section.
Okay, brilliant. The second question, so what is the biggest challenge we face in terms of putting these into practice?
I think just establishing some good practice is basically the hardest sort of thing there, right? Something that we all sort of canonically recognize or as good practice. And so I guess this is what a lot of talks on good practice try to do, right? It's sort of can say, okay, we have a few options here, and some seem better than the others, and just sort of working through what we do as a community, trying to figure out how we can get the most out of our languages, and then start putting those into practice, right? Writing blog posts, just this whole sort of mentality around thinking about things, giving feedback to each other, proposing better ways of doing things.
Okay, brilliant. We've got another question here from Brujo. So do you have any recommendations about the tools to use? He said, for instance, here he's got, excuse me if I say these wrong, Dialyzer, Credo, Elvis, Proper, Quick Check, anything else?
So there are a lot of tools, a lot of the ones that are listed there. I certainly, for example, like to use Dialyzer because just because the declaration there, the Dialyzer declarations are really expressive. Not so much for the correctness, but of course you get that, you know, to some degree as well. Yeah, there's Credo, which is a lot. Of course, there are tools making their way into a proper like the formatter. And like Jose has said, like the core team has said, it's not sort of, you won't give it your code and it'll fix it, and the format that it sort of spits out is ultimately what our code should look like. But if the formatter, for example, writes out some code that just does not look readable, then it's up to us to change how we structure that so that it makes more sense from a readability perspective. So some of the tools that you listed, but I feel like so much of of good practice is very difficult to capture in an automated tool, and so I'd say all of those are great. I stick a lot of tooling on my projects, and I did encourage our clients and customers to do the same. But I think we just have to be sort of more aware of some things and get them through in code reviews, for example.
Okay, so a nice mixture of both, really.
Yeah.
Okay. The last question we've got here is, do you have any, so it's similar to the tools, but do you have any reading suggestions beyond the other ones that you have referenced?
I have a general recommendation, which is basically to read widely. There are a lot of lessons from other communities for the functional programming languages, and so much of that we share, in terms of sort of syntactical constructs and things like that with lots of languages, right? Haskell has the list comprehension. There are so many things to learn if you're able to pull from other communities. And the reason why I'm saying that is because inevitably we're gonna read lots about Erlang and lots about Elixir. We're in this community already, right? If we're able to sort of expand out just a little bit, then there's so much we can learn and then start pulling that in. And so I recommend some list books, for example. Paul Graham's book is sort of really, well, I wouldn't say it's hardcore in any way, but it's sort of informal, sort of at the same time. Some of the Haskell books, of course. I'm sure you know the Elixir and Erlang books there. So yeah, I guess the general reading recommendation is just to read a little more widely than just Erlang and Elixir.
Could start up your own book club, Joe. Some Erlang Elixir programming book club.
Yeah, maybe I'll post a list on GitHub somewhere.
Yeah, definitely. And if you want to send them over to us, we can put them on our social media as well.
Okay.
Okay, so that was our recording for this month. So have a look out for this in your inbox as well. We'll be sending it out specifically for people that have registered. And Joe is also going to be joining us in London next month for a meetup. And we're yet to put that online, but keep your eyes peeled for that one as well. But for now, thank you and goodbye. Thank you, Joe.
Thank you.
Bye-bye.
Bye.